Now let's discuss question number 55. It states here that for a regular k-sided polygon, let alpha of k denote its interior angle. Suppose n is greater than 4 is such that alpha of n minus 2, alpha of n and alpha of n plus 3 forms an arithmetic progression. The sum of digits of n is. So here this is a question related to arithmetic progression and a polygon. It is provided that here alpha of k represents the interior angle of a polygon, and you know that if a polygon is k-sided, then k represents its number of sides, and the formula for obtaining the interior angle of polygon is n minus 2, that is side minus 2. So this will be k minus 2 into 180 degrees upon k. So this helps me out to obtain the interior angle of the polygon, as it is being stated here that alpha of n minus 2 moreover alpha of n and alpha of n plus 3 forms an AP. These are in AP. So we have obtained here a relationship that twice of alpha of n will be definitely equal to alpha of n minus 2 plus alpha of n plus 3. Now let's substitute here n minus 2 and n plus 3 in this formula for interior angle. Through that you will obtain an equation that we have 2 into n minus 2 into 180 degrees here upon n is equal to n minus 2 minus 2 into 180 degrees upon n minus 2 plus I have here n plus 3 minus 2 into 180 degrees upon n plus 3. So this is an equation obtained in terms of the variable n. When you solve this equation, you will get here the value of n, where n is greater than 4. And on solving this, you obtain that value of n is equal to 12. You will find that n is equal to 12. Very first, you can cancel out 180 degrees by taking common from both the sides and simplify this to get the value of n. But in this question, you don't need here the value of n. You need to obtain the sum of digits of n. So I could definitely write here sum of digits. Here, sum of digits of n is definitely 1 plus 2, that is 3. So, out of the 4 options given in this question, you can clearly mark your answer that the correct answer representing the sum of digits of n is 3. That is found here in option B. I can write here answer for this question is definitely option B. I hope it is clear to you. Now let's discuss our next question. Now let's discuss this question number 56. It states here that the sum of 5 numbers in geometric progression is 24. The sum of their reciprocals is 6. The product of the terms of geometric progression is out of these 4 options. Now you know that when we take 5 terms of a geometric progression, it is easy to solve the question if you consider the terms like a upon r square, a upon r, a into r and a into r square. Here it is given that sum of these 5 terms is equal to 24. So if you take the sum of these 5 terms and you take out a common from that, you will get a relationship that here we have a upon r square plus a upon r plus ar plus ar square is equal to 24. So here you can see you can easily take a common from all the terms on the left hand side, and you can also take LCM. After doing that simplification, you will obtain here clearly you get 1 plus r square plus r cube plus r raised to the power 4 whole upon r square is equal to 24 upon a. Let's consider this to be first equation. Now next it is provided that sum of their reciprocals is equal to 6. So let's take the sum of the reciprocals, and I could write here that I have r square upon a plus r upon a plus 1 upon a plus 1 upon ar plus 1 upon a r square. This is equal to 6. So when you take LCM in the left hand side and you simplify this, here you will be resulting r raised to the power 4 plus r cube plus r square plus r plus 1 upon r square. This is equal to 6a. Let's consider this to be equation number 2. Now what will happen when you compare these two equations? You can clearly see their left hand sides are equal. So you can easily compare both sides of this equation. So I can write here from equation number 1 and 2. From equation 1 and 2. Here we get that the right hand side of these two equations are equal. That is 6a is definitely equal to 24 upon a. And here on simplifying this equation, I get that a square is equal to 4. So this is helping me out to get the two possible values of a. Therefore, I could say a is equal to plus minus 2. Now here a is equal to plus minus 2. I can definitely get here the terms of this equation as I can obtain here product of the given terms. Product of given terms will be equal to 2 upon r square into 2 upon r into 2 into 2r into 2r square. When you simplify this, here you get the product as 32. When you put a as minus 2, you will get the product as minus 32. But when you see the options provided to you, out of these 4 options which are clearly positive, I can definitely say here the correct answer representing the product of the terms of GP is option B, that is 32. You can write here the answer for this question is option B. So I hope this question is clear to you. Let's proceed to our next question. Now let's discuss the question number 57. It states that digits A and B are such that the product of 4A1, which is a 3-digit number, and 25B, which is also a 3-digit number, is divisible by 36 in base 10. The number of ordered pairs of AB is out of these 4 options. Here you can clearly see we are talking about two 3-digit numbers and their product. So here A and B are numbers such that product of these two will be divisible by 6. So if you put here B as 2, then you will be obtaining here we have 4A1 into 252. This is clear multiple of 36, so this will be definitely divisible by 36 irrespective of the value of A. So A is a single digit, it could hold any values from 0 to 9. So A possibly 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have considered here the first case. If B is 2, A could have these possible 10 values. That means we have here 10 pair of values for A and B. The next possibility arises if you take A equal to 4 and B equal to 6. You will be obtaining here the number 441 into 256. Now this product is also divisible by 3. So when you take up the all possible values here, how many values are there? You can see here we have 10 possibilities and here we have 1 possibility. So here we get firstly the 10 possible values considering B equal to 2 and then one more possibility taking A as 4 and B as 6. So when you take up the number of ordered pairs, I could write here number of ordered pairs of A and B satisfying the given conditions of the question is definitely equal to 10 plus 1, 11. But when you observe the 4 options provided here, we have the option 15, 8, 6 and 4. We do not have any option for 11. Options are not clearly given to you. So you will be getting definitely grace marks for this question. The correct answer should be 11. So one of the options in this case should be 11. Now let's discuss our next question.